ever wonder how much momentum is present in your body when you're in motion? Try to think of condition of a small bullet projected at a high speed and a massive tanker ship moving slowly. Both conditions show great momentum. Momentum can simply be defined as the mass in motion. So whether it is a car moving, a person running, or a ball rolling, it has momentum. Momentum depends upon the variables mass and velocity. The equation for momentum is equal to the product of mass and velocity of an object. It is mathematically expressed in the equation P is equal to mv, where P is the momentum, m is mass, and v is velocity. The momentum of an object is expressed with the SI unit kilogram meter per second. The momentum of an object is directly proportional to both its mass and velocity. This means that if an object increases either its mass or velocity, the momentum also increases. If an object changes its momentum, it experiences impulse. It happens when force is applied against its motion in a given amount of time. Mathematically, impulse is expressed as delta P is equal to F delta T. The relationship between impulse and momentum is stated in the impulse-momentum theorem, where impulse applied to an object will be equal to the change in its momentum. To calculate the impulse, we need to subtract the initial momentum from the final momentum. Let's study the scenario given. The impulse-momentum theorem describes the conservation of linear momentum. The law of conservation of momentum states that the total momentum before a collision is equal to the total momentum after collision if no external force is applied on the system. An example of conservation of linear momentum is bowling. When the player rolls the bowling ball, it begins to move and develop velocity. This means that after and during the collision, the pins begin to gain velocity and possess momentum. So, to sum it all up, objects in motion possess momentum. The change in momentum is called impulse, and the impulse-momentum theorem describes conservation of linear momentum. See you next time!